Hello everybody, welcome to Test 4 review in Recalculus. As always, you see the list of the question or the list of the topic on the top. For Test 4, we're going to have the first 31 question, and then I forgot that we also have to have the question on the Conics section. Right, so we start with that first. On the 32 to 35, we have the question on the parabola. Alright, the parabola. So either we go with start with x, or we start with y. If we start with x, this is open up or down. If we start with y, it will be left or right. Up or down or left or right depends if we have the plus or minus in front of the 4a. Right. Now, the features of in the parabola, the most important is the vertex. The vertex will be at h and k. So look at the first one. We have the vertex as 4 and 3, x equal to 4, y equal to 3. So that is the vertex 4 and 3. The focus is 7 and 3, x equal to 7, y equal to 3. This is the focus 7 and 3. The distance from the vertex to the focus is 3, and that actually a is going to be equal to 3. Right, we determine that later. Right, next, if we want to, we can find the directrix, which is on the opposite direction of the focus. So the vertex right in the middle, focus on one side, and the directrix on the other side. This one, the focus on the right, so the parabola have to open to the right. And the vertex in this particular case 4 and 3, so open to the right, it has to start with y, and to the right this will be h. That doesn't matter, I change that later. Right, it's open to the right, had to be y minus something and x minus something. 4 on the x of the vertex and 3 on the y for the vertex. And this one open to the right, so it will be a positive coefficient here. Y a equal to 3, so we substitute that in for a. So the equation is y minus 3 squared equal to 4 times 3, so it will be 12 x minus 4. And that's all we have. Next, the vertex is at a and 3. X equal to a, y equal to negative 3. That is the vertex. The focus is 8 and negative 5. We go from the vertex to the focus 2 unit, a equal to 2. Because the vertex there and the focus here, the focus is at below the vertex. Focus is below the vertex, so it have to open down. It always go through the vertex and around the focus. The directrix, if we need to, will be on the opposite direction. So we start with the parabola that open down. If it open down, we have to start with x minus something square equal to 4a y minus something. This one open down, so it have to be negative. It has to be negative. Right. The vertex is a on the x and negative 3 on the y, and then we just substitute 2 into it. and that's what we do. So we have x minus a squared equal to minus 8y plus 3. You have the formula for the all of this conic section, but that's just a way to check it. We don't even need to use those formula. As long as you know that for the parabola we have the vertex in the middle, focus on one side, directrix on the opposite side. Wherever the focus is from the vertex, that is the direction of opening of the parabola. And then that, of course. 34. Now we find the vertex, focus, and directrix of this equation. This is y minus something. If it's y minus something, it's left and right, because the easiest one is y equal to x squared, that open up, and everything we can deduce from that. So x squared is up or down. So if we want left and right, it has to be y squared. So y squared here, that left and right. Right. So let's just copy that equation. The standard form of the equation is y minus something equal to 4a x minus something. This one is positive, so definitely it open to the right or open up. In particular, y squared, so it's open to the right. The point here is 4 and here 3, so 4 on the y and 3 on the x. So the vertex, we have 3 on the x coordinate and 4 on the y coordinate. 3 on the x, 4 on the y. That is the vertex. And we have 4a is equal to 12. So a is equal to 3. So the distance from the vertex will be 3. And remember, we did say that this one open to the right. So we have to go 3 units to the right to have the focus, and 3 units on the opposite direction to have the directrix. So we will have the focus. The y coordinate is the same, but x 3, 4, 5, 6, 3 units to the right, it is 6, and the directrix is x equal to 0 or the y axis, and the parabola open like this. That's 34, and then 35. So on the parabola we go from 32 to 35. Right. 35 we find the vertex, focus, and directrix. We're not given anything but the equation, not even in the standard form. But we do know that this is a, sorry. We do know that we have the x squared here. If it is x squared, remember, if y equal to x squared, that's just a parabola that open up. So this one open up. Just denote that somewhere. Right. Put that in the back pocket. Right. To turn to the standard form, we're going to add something here and something on the other side to balance it. We'll take half of the middle coefficient, half of that give us -4, and then we square it. That's 16 to the other side as well. So we just have x minus 4 squared equal to ay minus 40. We can factor out 8. Y minus 5. Right. From here we can get the center. Sorry, no center in parabola. only vertex. 4 on the x-axis, 4 on the x-coordinate, and 5 on the y-coordinate. So that is the vertex x equal to 4, y equal to 5. Right. Now if we compare with x minus something square equal to 4a, y minus something, a is equal to 4a, so a is equal to 2. Now, meaning that 2 is the distance from the vertex to the focus. We didn't know that. We know that it opened up. So from the center, from the vertex, we will have to go up 2 units to go to the focus. So the focus has the same x component, but the y have to be 2 units up from 5. So 5, 6, and 7. The directrix will be on the opposite side. Directrix is y equal to 3. And the problem, if we want that to be accurate, when it go to the focus, that is the length of lattice rectum will be 4 times this distance. So this distance we multiply by 4, so it's about this much, and the parabola is something like that. Alright, so that is the parabola. We have 36, 37 to 39. That is for the ellipse. Right. First, the ellipse, the most important. Remember, let's just review real quick. Parabola, vertex in the middle, focus on one side, directrix on the other side. And for the ellipse, center in the middle, and then vertices, 4 sides, all of them will be on a line. Right. So in this case, let's just put everything in the general form. It is going to be x minus something square over something square plus y minus something square over something square equal to 1. Now, the center, in this case, it is always minus, but if it to get to plus 1, we have to have, in this case, 2 here and minus 1. Minus negative 1 turn to a plus, right? To get the 16, that is 4 square, and 3 square is give us 9. Right. So from this equation, we see the center is 2 on the x-coordinate and negative 1 on the y-coordinate. 2 on the x-coordinate, negative 1 on the y-coordinate. Right. Next, we have the 4 that is under x, because x is the horizontal component which goes left and right. So we go 4 units to the left and right here, and 3 units up and down because that below the y. So 4 units up, 4 units left and right. 1, 2, 3, 4. 1, 2, 3, 4. So the ellipse look like this. Kind of. Right. We know the center. Now the foci and the vertices. Notice that the vertices are the point that are the furthest away from the center. So we know that this is 4 units away from it. So A equal to 4, and with that the vertices 4 units away from it. So the y component should be the same, but the x is either 4 to the right or 4 to the left. 4 to the right, 2 plus 4 is going to be 6, and 2 minus 4 is minus 2. So we have 2 vertices. And if we have the box like this, 4 left and right, and then 3 up and down, so b is equal to 3, and the foci will be, this is somewhere in there and there. The distance from the foci to the center is c, and we don't know c. Good thing is we know a and b. A is the biggest distance, so it will stand by itself, and b squared and c squared on the same side. So we solve for c squared equal to a squared minus b squared. 16 minus 9 is 7. So c is plus or minus square root of 7. That gives us the foci. The foci, we still have the y component of negative 1. But the x values start from 2. It can go square root of 7 to the left, or 7 square of 7 to the right. So that's why we have the foci is this, the vertices, and the center. It's nice to know the formula as well. You will be given the formula on the test, but it will be better to do the problem without the formula. So in ellipse, a characteristic of an ellipse is b squared plus c squared equal to a squared. For the parabola, it will be different. Right. This equation, all we need to do is turn the right hand side equal to 1. So we have to divide both sides by 324. Right. So let's bring the calculator up. 324 divided by 36. That's fine. 324 divided by 36. That gives us 9. So it's 9. So we're going to have x minus 3 square. 36 and 324 cancel out. We have 9. And 9 324 cancel out. We have 36. Right hand side is 1. Again, we have x minus something square over something square plus y minus something square over something square equal to 1. Right. And in order to have 3, we have to minus 3 to it. So that's good. To get the plus 3, we minus 3. So the center in here is at 3 on the x coordinate and minus 3 on the y coordinate. X equal to 3, y equal to negative 3. Right. Next, if we want to plot to get 9 square, that is going to be 3 square and 6 square. So 3 unit under the X, so that will be left and right 3 unit, and then 6 unit up and down, 3 up, 6, and so we have that box, and the ellipse fit inside that box. Kind of like that. Now we do have the center at 3 and negative 3, and we go up and down 6 units. That is the biggest distance away from the center, so that 6 unit up, that is A is equal to 6, and with that the vertices 6 up, 6 down from here, so the X component must be the same. We go 6 unit up, negative 3 plus 6 is 3, and negative 3 minus 3 is negative 9. So those are the vertices. The distance from the center to that is B, so A is 6, B is 3, and the fourth side will be somewhere in here. The distance from the center to a focus is C. We don't know what it is, but we do know A is the biggest one, which stands by itself. So B squared plus C squared equal to A squared. B we know is 3 squared, C squared don't know, A squared is 36, or 6 squared. So C squared 36 minus 9, 27. So C is square root of 27, which is 3 square root of 3. So to get to a focus, we go 3 square root of 3 up and down. The X component still stay at 3 up and down, so we just add or minus 3 square root of 3 to it, and we have the focus. Right. 38 and 39. We have the focus at negative 4 and 1, and negative 4 and negative 5. So we're going to plot those points first. Negative 4, x equal to negative 4, y equal to 1. That is one focus. And negative 4 and 1, and negative 4 and negative 5. That is another focus. The center must be right in the middle. So with that we have the center at x equal to negative 4 and y equal to 2. So sorry, yeah, negative 5 and negative 4, negative 5, negative 4 and 1. The center will be right in the middle. And I forgot that the y had to be negative 2. Alright. So in general the equation is x minus something square over something square plus y minus something square over something square equal to 1. Right. We know the center is negative 4 on the x coordinate and negative 2 on the y coordinate. So that would be x plus 4 square and then y plus 2 square. Right. Determine the one that is below the box. It says that the length of the major axis is 10, meaning that this is 2a. So a is equal to 5. And since the focus aligns vertically, A have to be, I mean, the major axis have to be up and down as well. It is 5, so we go up 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are the vertices. And the distance from the vertex to the center is 5. A is from the center to a vertex. This one only asks for the equation. We don't need that, so we know A is 5. The distance from the center to a focus, that is C, is 3. C is equal to 3, and C is from the center to a foci, to a focus. So we have A, we have B, we have C. We should have B. A squared equal to B squared plus C squared. A is the biggest one, so stand by itself. 5 squared. B we don't know, and C squared 3 squared. So from here we have B squared is equal to 16, or B is equal plus or minus 4. So the B, so on here we know that A is 5 and B is 4. Just need to put them accordingly. Notice that since this is up and go up and down to get to the vertex, you have to put 5 under the Y and then 4 under the X. So we go 4 units left and right. 1, 2, 3, 4. 1, 2, 3, 4. So we have that box. And we have the ellipse carved like that. So that is 38. And now 39. Kind of the same thing. We have two foci, 1 and 5. X equal to 1. Y equal to 5. And x equal to negative 7. Y equal, I don't know why I got there, but x equal to 1, y equal to 5, x equal to negative 7, y equal to 5. So there are two foci. The center must be right in the middle. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So center will be right there, which is negative 3 up 5. So the center negative 3 for the x coordinate and 5 for the y coordinate. Right. We have one vertex is at negative 8 and 5. And the distance from the vertex to the center, that is A. And we just count 1, 2, 3, 4, and 5. A is 5. And the distance from the center to the focus, 1, 2, 3, and 4. So again, A is from the center to a vertex. C is from the center to a focus. And then B squared plus C squared is A squared. So we know C, we know A. B squared equal to A squared minus C squared. A squared, A, 5, 4. So B squared is 9. So B is equal to 3 plus or minus 3. So we go right, determine that later. By the way, on the previous example, let's just change that equation to x plus 4 square over 4 square, which is 16, plus y plus 2 square over 25 equal to 1. Let's write equation in that form instead. Right. Now in this we have x minus something square over something square plus y minus something over something square equal to 1. We do know the center is negative 3 for the x coordinate and 5 for y coordinate. And then we go left and right for the foci and the vertices. So they have to be x component, so it'll be left and right 5 units. So we're going to put 5 here, and then b is the other one. Rewrite the equation. We have x plus 3 square over 25 equal to y minus 5 square. I should write plus here, equal to 1. Right, so the 9 under the y minus 5, so go up 3 units, 1, 2, 3, 1, 2, 3, draw the box. Right, 5 units left and right, 3 units up and down. We have the ellipse like that, the foci right there. Right, so that's what we have for 39. Next we have 40 and 41. We have two questions on the hyperbola, 40 and 41. Right, for the equation of hyperbola with the center at 7 and 6, center 7 and 6, x equal to 7, y equal to 6. That is our center. A focus is at 1 and 6, x equal to 1, y equal to 6. That gives us a focus. Right away we can see the distance, 1, 2, 3, 4, 5 and 6. The distance from the focus to the center is always c, in this case 6. 1, 2, 3, 4, 5 and 6. C equal to 6. And then a vertex is at 6 and 6. 6 and 6. So vertex is x equal to 6, y equal to 6. So that is a vertex. Distance from the vertex to the center is always a. In this case 1. Notice that if we have a vertex there, we have the vertex on the opposite side, and the focus there will be another focus on the other side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's another focus here. Right, so we have C and A, then we can find B easily. Notice that the focus to the center, in this case C is the biggest one, so we have, instead of H square equal to B square plus C square, in this case C is the biggest one, therefore C square stand by itself, A square plus B square. So we have B square equal to C square minus A square. C square 36, A is 1, so 35. So we have B as square root of 35. Let's just get an approximation. Square root of 35 is about 5 point something. It's 5.9. So if A is this left and right, then B is have to be up and down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and something. 1 2 3 4 5 and then little something, and then we have A is from the center to the focus, so we only have this much. So yeah, that box like that, and we can draw the diagonal. And this is a parabola open left or right because everything aligns horizontally, so it must be open left or right, left and right, I should say, like that. Right, so equation, because it open left or right, left and right, it will start with x. If it open up and down, it will start with y. So we start with x minus something square over something square minus y minus something square over something square equal to 1. Right. So the center in this case 7 and 6, 7 for the x coordinate and 6 for the y coordinate. We did go only one unit left and right, but then square root of 35 up and down. So pretty much that is the equation. X minus 7 square minus y minus 6 square over 35 equal to 1. So that is the equation. 41. Find the center of vertices, cosine asymptotes of the parabola. That one. So first, in this case, it starts with the x, so we gonna write like that, and then determine what each component does. Right. In order to have plus 2 and minus 1 here, we're going to have minus 1 for the x and minus 2 here, minus negative 2 give us a plus 2. So and then this one under the x, so it's going to be 2, and under the y 36, so that's going to be 6 squared. So that is the equation. So from this equation we can see that the center must be at 1 on the x coordinate and negative 2 on the y coordinate. Let's start with that. X equal to 1, y equal to negative 2. That center. Next, on the x, go left and right 2 units to the left, 2 units to the right, and 6 up. 1 2 3 4 5 6, and 6 down. 1 2 3 1 2 3 4 5 6, and we draw the box. Right. Again, 2 left and right, 6 up and down. Next, this one we start with x squared minus y squared, so it's going to be horizontal. So it open to the right and to the left. So the vertex had to be right here. So the vertex or vertices. The y component will stay the same because we have the same height. But the x, we go 2 units to the right. 1 plus 2 is 3. And then 2 units to the left. Minus 1 and 2. 1 minus 2 is negative 1. So that's what we have. The fourth sign will be, I guess, somewhere in here and there. We do know that go left and right 2 units. We have A is equal to 2. B is up and down, so 6. C is going to be the biggest one of all. So A squared plus B squared C squared equal to C squared. So A squared is 2 squared, 6 squared equal to C squared. So C squared equal to 6 squared, 36 plus 2 squared, 4, so 40. So C equal to square root of 40, which is square root of 4 and square root of 10. So C is equal to square root of 10. So if we want to go to the fourth case or go to the fourth sign, we start from again 1 and negative 2 is the center. All the y values will stay the same, only the x will change. So we have the plus or minus 2 square root of 10. Y is still negative 2. So that gives us the fourth sign. And finally, the equation of asymptotes. It's going to be y minus something equal to the slope x minus something. That something is exactly like the center, where we have negative 2 on the y and 1 on the x. And in here we have plus or minus the slope. We go up 6 over 2. So slope is rise over run. So we have y plus 2 plus or minus 3 x minus 1. That is the equation of asymptotes. And we have all the center vertices. This time everything will align horizontally. Center, vertices, and foci, all of them on the same line. So that's what we have. Right. So that is question 32 to 41. Now we go from back to 1 to 31 for the other topics. Classify conics. Right. So to classify conics, first the equation in general is, I have to write that somewhere here. Let's say ax squared plus bxy plus cy squared, and then doesn't matter what happened after that, equal to 0. And then we compute the discriminant, the b squared minus 4ac. If it is greater than 0, greater than should be above, that hyper is also means over. So when it's greater than 0, that is hyper parabola. If it's less than 0, it will be ellipse. Equal to 0 will be parabola. So now particular problem, a is equal to use blue. A equal to 1, b equal to 10, and c equal to 25. So b squared minus 4ac, b squared minus 4ac, 100 minus 100, that is 0. If it is equal to 0, it will be a parabola. And the next one we do the same thing, very straightforward. B squared minus 4ac bigger than 0 hyperbola, less than 0 ellipse, equal to 0. That is a parabola. So we use that, and I'll let you do question 2. Next, convert rectangular equation into polar equation to rectangular equation. So this we will have x equal to r times cosine theta, y equal to r sine theta, and then r is x squared plus y squared, so r squared is x squared plus y squared, and tangent of theta is y over x. So we have those formula that we can use. So now we convert this equation into rectangular equation. Rectangular equation meaning only x and y in it, and not r and theta. So when we look like this, the natural thing, the first thing we can do is just cross multiply. So in that case, we have 2r. Say r equal to 2 minus 2 cosine theta equal to 2. Right, I will multiply it out. 2r minus 2r cosine theta equal to 2. Right away we see, every time we see r cosine, that is going to be x. So we have 2r minus 2x equal to 2. By the way, all of them have 2, so why don't we just divide everything by 2? That simplifies a lot of things. So do that, we have r minus x equal to 1. Divide everything by 2. Right, and then move the x on one side. The reason of that, because we need to have r squared. If we square both sides, we have r squared equal to 1 plus x squared, where r squared is x squared plus y squared equal to 1 plus x squared. Right, so that's all. As long as we have x and y, that is good. So not only we go from polar to rectangular, we can also go from parametric into rectangular equation. So we have something, I should put a rectangular equation, something like 3. Actually, we did 3, 5, and 6. 5 and 6, there are two ways to eliminate eliminate the parameters. Again, the question asks us for the rectangular equation, so I have to have x and y in it. So the easiest one is just solve for x in terms of y, and solve for y. So for t in terms of y, or solve for t in terms of x. I look at this equation, and I say if we just minus 3 on both sides, we have y equal to, t equal to minus 3. And then we substitute into this. We have x equal to 3 times y minus 3. That's pretty much it. We have x and y in the equation. That's all we do. But it would be better if we can just solve for x and y. But that's not really important. That is the equation. That's all we need. Right. What we do need though is, because negative 2 to 3, that is the limit for t. What we have is the limit for y. So instead of this, we need the y minus 3. we need y, but y is equal to t plus 3, so why don't we plus 3 on both sides here, and with that we have t plus 3 is between 6 and 1, and t plus 3 is y. So the answer is we have this equation that has only x and y in it, and where y is between 6 and 1. So the equation will have x and y, and this is a domain if it's possible. Right, so that's good. Unless, of course, if we have sine, cosine, then that will be different. Unless we have sine, cosine, and that will be different. What we do in that case is we solve for sine and cosine by itself. So we have sine t equal to x over 4. Cosine t is y over 4. Now if we square both sides, we have sine square equal to x squared over 4 squared, which is x squared over 16, and then cosine square y over 4, which is y squared over 16. Add side by side, sine square plus cosine square equal to 1. I'm sorry. Sine square plus cosine square on the left hand side. The left hand side is equal to 1 because we have sine square plus cosine is 1. The right hand side we have x squared over 16 plus y squared over 16. So yes, the equation is x squared over 16 plus y squared over 16 equal to 1. And then if we're going to sketch that real quick, 0, 0 for the center. This is the ellipse, by the way. 4 up, 4 down, left and right. So that's actually a circle. So we can say that is the equation where x and y have to be between 4 and negative 4. That's not necessary. At least you have to give the equation in rectangular form, which is only have x and y in it. And again, if we have sine, cosine, the best way to eliminate the parameter is to get sine square and cosine square. When we add them, sine, cosine, sine square plus cosine square is 1, and we don't have the parameters anymore. So that is rectangular equation. Next, we write the parametric equation. So this is opposite direction. This time we have the y and x. We just write in terms of x and in terms of parameters. So if we have the equation, the easiest one and the laziest one is the most lazy one is just when we just let x equal to t. So in that case, instead of 2x minus 5, we have 2t minus 5. So we say x equal to t, y equal to 2t minus 5. So that's what we have. Seven. Again, now if we have the square like this is the ellipse, so we turn that into sine, cosine. So x squared over 64, y squared over 81 equal to 1. Now, we do know the form of cosine square plus sine square is equal to 1. Just need to match into the right one. So we could match x squared over 64 with cosine square, or x squared over 64 with sine square. It doesn't really matter if it is not specified. But this one, yeah, there's no specification, so we just say x squared over 64 is cosine square. If we don't have anything that's specially uh, given, then we just usually we go x with cosine then y with sine. I mean like that. Right. Multiply 64 on both sides. We have x squared equal to 64 cosine square t. Y squared is 81 sine square t. Taking the square root on both sides, we have x square root of 64, which is 8 cosine t, and y equal to 9 sine t. If we want the whole ellipse, t has to be between 0 and 2 pi. Again, if it's not specified, we still can go from 0 to 2 pi. So if we have something square plus something square equal to 1, that screams Pythagorean identity, and then we just match one with cosine square and one with sine square. And that's all we have. Partial fraction. Right. We do a few things here. Partial fraction we have from 9 to 12. 9 from 13 actually. We're not going to do all of them. But first, get the form at least. So in the first one, we're going to have x minus 2 at the bottom. X minus 4. That's the easiest one. Remember, the top we cannot have more than the bottom. Degree cannot be more than the bottom. And multiply by the least common denominator, simplify, and then solve for a and b. Instead of doing for 9, we start with number 10. We have something over x, something over x plus 1, something over x minus 1. The degree on top cannot be more than the bottom. So I will multiply both sides by the least common denominator of x, x plus 1, x minus 1. So if you multiply everything by that to everything, the bottom cancel here. So we just have 2x squared minus x minus 9. That's the left hand side. The right hand side we have a. We have x already. Cancel with that x. So we have a times x plus 1, x minus 1. And then b, we have the x plus 1 already. We have x and x minus 1 left. The next one we have x minus 1 already. We have x and x plus 1 left. Right. So just need to do this real quick. So we will have that, just need to multiply it out and solve for the coefficient. I'll keep the 8 here. X plus 1, x minus 1 give us x squared minus x plus x minus 1. B, that gives us x squared minus x. C, x squared plus x. Now we multiply it out. Minus x plus x cancel out. So that is ax squared minus a plus bx squared minus bx plus cx squared plus cx. Combine like terms. We have ax squared here, bx squared, and cx squared. Factor out x squared, we have a plus b plus c. Next, negative bx and cx. So if we factor on x, we have negative b plus c, and the constant a by itself. The left hand side is 2x squared minus x minus 9. Now we just match. The square must be equal to the square. That gives us a plus b plus c has to be equal to 2. Negative x have to be equal to this, so negative b plus c has to be equal to negative 1. And finally, negative a is negative 9. That one obvious. Right. Even though we can do it by hand, I usually just use a calculator. Or systematically, it is better that way. Right. So again, if we use a calculator, this is how we do it. Hit the second matrix, go to math, and go down to option RREF, and now we put the matrix alpha zoom. This one has 3 rows and 4 columns. So coefficient 1 for A, 1 for B, and 1 for C. 2 is the number on the other side. No A, I should put 0 there. Negative 1 for B, 1 for C, and negative 1. Negative 1 for A, no B, no C, and negative 9. Oops. On the other side. So the A, B, C, the coefficient on the left hand side, we have to have one more for the constant on the right hand side, and we do that. On the test, we need to do just REF here. A equal to 9, B equal to negative 3, and C equal to negative 4, because that's what we have in the last column here. Right. Bottom line is when we put all of that together, we should have the partial fraction decomposition of original problem to x squared minus x minus 9 over x plus 1, x minus 1. A over x, A is 9 over x, B negative 3, x plus 1, and negative 4, x minus 1. So that is the partial fraction decomposition of that big fraction. Right. So when we have the system equation, I recommend we use the calculator to solve for it, especially when we have more than 3 variables. Right. 11. I'll just write the form. Notice now that we have the x plus 2 and x plus 1 square. For x plus 2, we just have that. For x plus 1, because of the square, we have to have one more, but this time it is square. The top decrease be just ABC. As long as it's the linear factor, we just have constant on the top. If this one square, we have that. Right. We're not going to do this one. I'll let you do that one. Right. 13, write out the form of this one. Okay, get back to that in a minute. Right. So on this one, we're going to have x minus 1. That one easy. And this one is square. Remember, if it is over the linear factor, the top it says A. If it is over quadratic, the top degree is always one less than the bottom. Let's go B x plus C. Right. If it is in this form, then we're going to write something over x squared plus 5 and something over x squared plus 5 squared. The top is ax plus b and cx plus d. Again, if it is over a quadratic, it is something x plus a constant. If it is over the linear, then the top is just a constant. We're going to do number 12 here. So the least common denominator is x minus 1, x squared plus x plus 1. Alright, multiply. This one has the whole denominator, so that cancels out. On the left hand side we just have 10x plus 2. The right hand side we have a x minus 1 already, so we have a times x squared plus x plus 1, and then bx plus c. It has x squared plus x plus 1 already, so that cancels out. We have x minus 1 on the top. Now we multiply it out. Ax squared plus ax plus 1, and then plus bx squared minus bx plus cx minus c. Right, bx squared minus bx plus cx minus c. Right, combine like terms is my favorite part of the problem. Ax squared bx squared. If we factor out x squared, we have a plus b. We have ax minus bx plus cx. If we factor out x, we have a minus b plus c. And we cannot have the number by itself like this, so actually x squared, ax, and a cannot have number by itself. A minus c, and then we match. There's no x squared on the, I just copied that first. No x squared on the left hand side, so we have a plus b equal to 0. A minus b plus c, match that with x. Coefficient must be equal to 10, and a minus c have to equal to 2. That is our system of equation. Again, we use the calculator to solve for it. Second matrix. Go to math, option B, RREF, and then enter the matrix. 3 equation, 3 rows, 3 for 3 variables, and 1 for the last, for the constant, so 3 and 4. 1 for A. Don't hit the enter in this case, just hit next. Hit the arrow, use the arrow here. 1, oops. 1 for A, 1 for B, no C, 0. 1 for A, minus 1 for B, 1C equal to 10. 1 for A, no B, negative 1 for C, and 2 for the other number. We have that. So again, on the test, all we need to do is just plot the arrow RREF. A is equal to 4, B is equal to negative 4, and C equal to 2. So when we decompose this, we will have a over x minus 1 4 over x minus 1 b negative 4 x plus 2 x squared plus x plus 1. So that is the partial decomposition of that big fraction. Right, so we have the partial fraction. I forgot then we just have the sequence in general. Right, in the term of sequence, we have this kind of problem. And then there's this summation notation as well. Right, so let's look at 14 to 19. Right, 14. I'll find the first four term who's given by this, so that should be easy. So the first four term meaning that what is a1, a2, a3, and a4. We just put 1 in here for a1, 3 to the first power 1 plus 3 factorial, which will mean we have 3 over 4 factorial. 4 factorial is 4 times 3 times 2 times 1. 3 cancel out, 1 over 8. And then next 2 for n, so we should have 3 plus 2 factorial. That gives us 9. 5 factorial, 9 over 5, 4, 3, 2, 1. That is 120, which is 3 over 40. Right. It's better we can also use the calculator here. So I will hit y equal to alpha y equal to get a fraction. The top 3 to the n power, just use x. The bottom n plus 1, and then factorial. Factorial is under math, PRB, probability, there. And we hit second table. That's what we have. So the first term, n plus 3. And then second table. Right. First term 1 over 8, 3 over 40, 3 over 80, and 9 over 560. So just like that, if we have the formula. Right. I'll skip 15. 16. And then 17. Right. Write the sum using summation notation. So we're going to write that as the summation notation. Right. The pattern here 2, 4, 6, 8, 10, and then so on. So if we associate that to the index, we can write 2 times 1 plus 2 times 2 plus all the way to 2 times 9, if we could write like that. So it's going to be 2 times something, where that something go from 1 to 9. That's all we do. This one is going to be a summation. On the top we see 1 1. Now that's strange. Those are the same number, so it's much better if we multiply 2 top and bottom. Now let's write 1 over 3, 2 over 4, 3 over 5. Now that make a lot more sense. As you see, the number on the bottom is 2 more than the top. So if we have the top is just k, the bottom is going to be k plus 2. It is 2 more than the top. And the number corresponding to the top goes from 1 to 13. So that's what we have. Alright, next, 18 and 19. Now we evaluate the summation. If we do that by hand, just going to put the numbers in. We start from 1, and then 2, and then 3, and then 4, and then we stop at 5. So 12, 13 to 16. So we just do that by hand or calculator. Remember, 12, 13, there are much better way to do this. We have 30, 70. Now we use the calculator. We need the summation, right? So hit alpha y equal 2. We don't have that. How about this? Right, so just hit alpha Windows or just alpha y equal 2. If you don't see it, go to the next one. If you don't see that, go to the next one. So in that case, the second one is the summation. So that's one way to do it. The other way to do it is just hit math, go all the way where it says summation. There. And we have k. Let's use x instead. 1, x equal to 1, 2, 5. It is x plus 11. And of course, be just that. The next one, we have 3 to 5. So we're going to put 3 in. And we do by hand or the calculator. Again, math, go to option, summation. And 53. So that's what we have. Next we have arithmetic sequence and geometric sequence. I need to put the calculator away. Right, arithmetic sequence explained a lot more in class, but arithmetic sequence we have 20 to 24. I skip 24. And then geometric we have from 25 to 30. Right. Arithmetic sequence, there's 2 formulas for it. I explained a lot more in class, but we just have The n term is going from the first term. We're going to take n minus 1 step to d, and the sum is equal to n over 2, the first term plus the n term. Right, so pretty much there's only two formula, the n term and the sum of the first n terms. Right, for the n term, so that's one obvious, put everything in it. 13 for n, we have a1, which is 7, and n minus 1, 13 minus 1, times d, negative 1. So put all of that in this formula, and that's what we do. 7, d is negative 7, sorry. So let's use a calculator quickly. 7 plus 13 minus 1 times negative 7. It's better just put negative 7 in the parentheses. We have negative 77. That is number 20. And that's all. For the 23rd term in the arithmetic sequence, given like this, the 23rd term, that is a of 23. So we have an equal to a1 plus n minus 1 times d. What we have is the first term is we start from 0, and we're going to plus 6 every time. In particular, if they're 23, so we're going to do 23 minus 1. So we have 0 plus 22 times 6. That is 132. So again, if we want a particular term, it's going to be that. If we want the sum, it's going to be this. By the way, let's keep 22 here. So find the sum of the arithmetic sequence like this. What we see is, in this case, we know the first term is negative 6. We know the n term is 39. This problem asks for the sum, by the way. So we can use this formula here, which is that. The only problem with this is, in this case, we don't know what n equal to. We do know this is equal to an though. We let that equal to an. So an equal to 39, and an is equal to that formula. A1 plus n minus 1 times d equal to 39. We do know the first term is negative 6. We do know that in order to go from this term to the next, as you see, we have to plus 5 every time. Plus 5, plus 5, plus 5. Now, plus 6 on both sides, we have n minus 1 times 5, plus 6 on both sides, that is 45. Now, if we divide by 5 on both sides, we have n minus 1 equal to 9. And then plus 1, so n equal to 10. Yeah, so plus 6 on both sides, divided by 5 on both sides, and then plus 1, so n equal to 10. So s of 10, because n equal to 10, 10 over 2, the first term is 6, the n term is 39, so that's 45, and 45 times 5. 45 times 5. It is negative 6, I'm sorry. Okay, 10 over 2 is 5 times minus 6 plus 39, that's 33, so it is 165. Right. I also skip number 24. If we do that, just write out quickly, the brick staircase has a total of 14 steps. Each step require, the bottom step require, so we have an, the bottom step is 101 step, n equal to 14, that's 14 steps. Each successive step require 4 less bridge. So that means, so we start with a very small number, we just add more and more bridge into it. So difference will be 4. I'll just add 4 to it, and with that we have everything. To put in Sn equal to n over 2 a1 plus an. Alright, we know n is equal to 14. We know the last term is 101, we just don't know what is the first term. So let's write an equal to a1 plus n minus 1 times d. Put in everything we know. An is 101, a1 is, that's what we're looking for, n is 14 minus 1 to that 13, d is 4. Do that. A1 is equal to, calculator, 101 minus 13 times 4 is 49. So we have 49 is A1 and AN is 101. So we do that. 7 times 49 plus 101, that's 1, and we have 1050. It's pretty simple. Right, next we have the geometric sequence. By the way, let me check the list. Geometric sequence or geometric series, there will be a few formulas. So notice that if this one is an equal to a1 plus n minus 1 times d, the geometric sequence an is equal to a1 times r to the n minus 1. All of this formula you will be given. So a of 9 equal to a1 times r to the 9 minus 1, so which is a1 r to the 8 power. 9 minus 1 is 8. a1 is 5, r3 to the 8. Calculator, 5 times 3 to the 8 power, 32,805. Right, so the n term for geometric sequence is that. Let's do that again. a1 r to the n minus 1. So 26. The first term is negative 2. To get from this one to the next, we need to multiply by 3. And find the n term. So in that case, a of n equal to a1 r to the n minus 1. a1 is minus 2 times 3 to the n minus 1. That's all we do. So the n term is this. The sum of the first n terms. Again, all of this formula will be given. I will use this one. R to the n minus 1 over r minus 1. Right, in this sequence, the first term is 2. The ratio, to get the ratio, in order to go from this term to the next, we need to multiply by 2. So multiply by 2, by 2 by 2. So we have 2 for A1, 2 to the n, in this case 11 terms, so n is equal to 11. So pretty much we just have 2 times 2 to 11 minus 1. 2 to 11 is 2048, 2047, 40, 92, 94, sorry. Right, so sum of the first n term, I should match with this. Sum of the first n term is either this or either one of this formula will work. Just keep n here. So to get to the first 11 terms, that's what we do. And finally, this is the infinite geometric series, so the sum of the series that go on forever, geometric series. In that case, the sum is equal to a1 over 1 minus r, only if r is between, cannot be equal to, have to be less than 1 and greater than -1. Alright, so in this problem, we have the first term is -30. The ratio, you see that it's getting smaller and smaller. So in particular, it is multiplied by 1 over 5. That's what we have. Again, if we don't know the ratio, all we need to do is divide backward. -6 over -30. Just calculator. -6 over -30. That's 1/5. Like this from -6 divided by -2 is 3. So we just divide from this term to the previous one and then divide by the previous one, and that's it. So -6 over -30 is 1/5, and that we have those two terms. The first term is -30, the ratio 1/5. So we're going to do that. Alpha y equal to, by the way, in this problem we can use the formula because the 1/5 is between -1 and 1, so that's perfectly fine. -30 divided by 1 minus 1/5, and change that to fraction. -75 over 2. Next one. This sequence, this series, the first term is 1/4. Now what will be the ratio? The ratio is we're going to take this term divide by the previous one. So we have -1/2 over 1/4. Multiply reciprocal, -1/2 times 4 over 1, which is -2. And -2 is not in this. -2 is not between -1 and 1. Because of that, the sum does not exist. Yeah. So we find the ratio. In this case, the ratio is -2, which is less than -1. As you see, if we just keep doing like we have 1, -2, plus 4, -8, just getting bigger and bigger. In that case, we do not have the sum at the end. As opposed to this one, the number just keep getting smaller and smaller. Essentially, that sum will approach into a number, which is good. On this one, it cannot. It doesn't work like that because the number keep getting bigger and bigger. in terms of magnitude, of course, because the size they change. So if the number get bigger and bigger, we will not have the sum. The way to determine that is the ratio has to be between -1 and 1. 40, 30, we can write repeating decimals like this, which we can write as 4.45 plus 0.0045, and then so on. The first term is 0.45. The ratio is, calculator, 0.004 divided by the term before that, 0.01, which is good though. That is between -1 and 1. So we can use the formula a1 over 1 minus r, a1 1 minus r is this one we can do it by hand, 0.45 over 0.99. Let's move the decimal 2 places to the right. 45 over 99, both of them divisible by 5, so we have, both of them divisible by 9, so we have 5 over 11. And again, so geometric sequence, there are 3 formulas to get to a particular term. The sum of the infinite series. This only works if the ratio is between -1 and 1. If it doesn't, the sum does not exist. So there are 3 formulas for geometric sequence. And with that, we cover all the topics for the test 4. I hope this helped you to prepare for the test. Thank you for watching.